Assalamualaikum warahmatullahi wabarakatuh. Now I would like to present the materials that I have already learned in statistics. In the first and second week, I've learned about introduction to statistics. And for the introduction to statistics, the first one is I learned about the types of statistics. There are two types of statistics. The first one is descriptive and the second one is inferential. For the descriptive statistic is tell us the method of organizing, summarizing, and presenting data in an informative way. For the second type is inferential statistic, is a decision estimate, prediction, or generalization about population based on sample. For the second thing I've learned from this material is population and sample. Population and sample is very different. For the population is a collection of all possible individuals, object, or measurement of interest. For the sample is a portion or a part of the population. And a sample used because it's not possible to test all of the population, and it can minimizing the cost needed to test the population. So when do we want to test, we only test the sample. And for the next material is type of variables. For the type of variables, there are two types of variables. The first one is qualitative variables and the second is quantitative variable. For the qualitative variables, it tells us the non-numerical information, for example like gender, religion, state of birth. And for the quantitative variables, it tell us the numerical information, for example like balance in your checking account or number of children in family. And for the quantitative itself, it divided into two. The first one is discrete variable. For the discrete variable, it can only assume certain value. For example, like number of bedrooms, so the answer will be 1, 2, 3, 4, or maybe 10. For the continuous variable, it can only assume any value within a specific range. For example, like weight of pork chop or height of student. And there are four levels of measurement. The first one is the nominal level. So the nominal level, it can be arranged in particular order or may only be classified. For example, like eye color, gender, religion. They can be arranged who is the first and the second or the last, and only be classified. For example, like gender, there are men and women like that. For the second levels is ordinal level. So ordinal level data arranged in some order, but differences is meaningless. For example, like we do a test for soft drink, and we order it by the rank, based on the rank. For the first one, tastes very good, very delicious, very nice. Yes, maybe all yellow, and the second is bright. The third is 7-Up. For the last is orange crush, for example, like that. And the third level is interval level. So interval level is similar to ordinal, but the differences it has a meaning and the ratio between values. For example, like temperature on the Fahrenheit scale, stress size, like that. And for the fourth level is ratio level. It's like interval level, but it has a permanent starting point, which is 0. For example, like monthly income for surgeons, it started with 0. And for the distance traveled by manufacturer's representative per month, it's also stated with 0. And for our next material is frequency. So frequency is a group of qualitative data that show the number of observations in each class. Frequency exists as a numeric data from each qualitative data. The interpretation of frequency data is translated by the numeric data to become a descriptive sentence. For example, there are 25 women in our in our task. We do a task, and there are 25 women that involved in our task, and 75 men, and um, that involved in our task, and so the total will be 100 people. And so frequency usually showed at the present. So we got the women 25% and the men 75%. And from that data, we know that from our sample, 25% of our sample is women and 75 of it is men. To do a frequency test, we can do it by SPSS. So we can first input the data first at the SPSS and do analyze and frequency. And the next is validity and reliability. For the validity and reliability test, is a test to make sure that the indicators is valid and reliable to become indicators of a variable. For the validity test, we can conclude that that data is valid is we see from the correlation value. If it's more than 0.3, it means that the data is valid. For the reliability, and we can see it from the reliability coefficient. If it more than 0.6, it means that the data is reliable. So if the data has correlation value more than 0.3 and the reliability coefficient more than 0.6, it means that the data is valid and reliable. And the next is different tests. For the different tests, it has 4 types. The first is independent sample test, the second is Mann-Whitney test, and the third is One-Brianova, and the last is Kruskal-Wallis. To know a variable is using what method, we have to do the normality test first by Kolmogorov-Smirnov test first, and after that we have to pay attention in a significant number if it's higher or lower than 0.5. If the data is it has the significant point more than 0.5, so the data is abnormal. So the method we will use is Mann-Whitney for less than or 2 values, and Kruskal-Wallis for more than 2 values. If the data has a significant number more than 0.5, it means that we use independent sample test for 2 or less than 2 values, and One-Brianova if for more than 2 values. And the next is paired data. Paired data is the data sets are paired when the data sets has the same number of the data points, and each data points in one data relate to one and only one data point in other data set. And for the next material, I learned in statistics is correlation, and in correlation we can show whether and show how strongly pairs of variables are related. There are 3 possible correlation. The first one is positive correlation. It means that both variables increase or decrease at the same time. And the second possible correlation is negative correlation. An increase in one variable associated with a decrease in other variables. And the last is zero correlation. It means there's no relationship between 2 variables. And there is correlation coefficient, which can be symbol as R. The closer R to 0, the weaker the correlation it has with one another. To know the correlation between two data, we can use an Excel with the formula equal correl, and we can input the data in bracket. The example of correlation, there are two data, and for example, like our study and exam grade. And after we input the formula and we count, and we got the number of R, which is 0.86. This means that they have positive and strong relationship. So we can interpret like people who study more hours tend to do better on the exam, and those who study few hours tend to do worse on the exam. And the next material is about the regression. Regression is a set of statistical process for estimating the relationship between a dependent variable and one or more independent variables. There are two types of regression. The first one is linear regression. It's a linear approach to modeling the relationship between a dependent variable and independent variables. The second type is multiple linear regression. It's the same with the linear regression, but they have more than one independent variables. And to get the regression result, we can use Excel by using data analysis and regression. We choose the regression. The closer R squared to 1, the better regression line fits the data. For example, if quantity merchandise sold, it's equal with price and advertising. So price and advertising, it has an effect to the quantity of merchandise sold. Next things I learned is a dummy variable. In dummy variable, there is a logistic regression. It uses a logistic function to model a binary dependent variables. A binary logistic has a dependent variable with two possible values, which is 0 and 1. Dummy variable is to translate qualitative data into a quantitative data, which only can be classified as 1 and 0. For example, we have an example of dummy variable is gender, maybe gender. And there is women and female and female. So we can translate that classification of the gender. For example, female 0 or female 1 and male 0. And the next is we talk about multicollinearity. So multicollinearity can mean by perfect. It means that when the regression coefficient is determined and standard errors are infinite. How to detect? The first thing we can detect is first, it has high R square but few T ratios. The second, high pairwise correlation among regressors. And the third, auxiliary regression, it's X and another, and compare R square and R values. And the fourth, initial values and condition index. And the five, tolerance and variance inflation factors. And in the multicollinearity, the higher multicollinearity result in a larger R square, which they increase the standard error of the coefficient and tend to result in insignificant T statistic. And lower correlation coefficient, which can be simple as R, doesn't necessarily indicate that are a clear multicollinearity. Heterogeneity happens when the standard errors of a variable monitored over a specific amount of time are constant and tend to vary over time. And heterogeneity arises in two forms. The first is conditional, when identify constant volatility when future periods of high and low volatility can be identified. The second is unconditional, used when future periods of high and low volatility can be identified. And heterogeneity refers to error, variance or dependence of scattering within a minimum of one independent variable within a particular sample.